Okay, so I also wanted to explain how to measure moisture content. This is important for backfill samples in particular because we don't really control what the moisture content is in our backfill. We do for laterite and sand, but not for backfill, so we do want to measure that. And measuring moisture content is quite simple. You take the sample and you have to, when you collect it, you must keep it in a watertight container, like this one with a screw top lid, so that none of the moisture escapes. And then it's quite simple. You just weigh out your backfill sample, and then you take note of what that is. You leave it up to dry, and then all the moisture will evaporate, and then the mass of the sample will go down, and then you simply measure what that difference is, and then turn that into a percentage to get the moisture content as a percentage. And it's really quite that simple. This first bit is about sample preparation for coarse samples like a laterite or a backfill, something that has gravel in it. And the reason why we need to do this, take these extra steps at the beginning, are because the gravel samples will not run in the hydrometer. Now, in order to, there's a specific volume that the sample needs to be, weight that it needs to be in order to be in the work in the hydrometer. So what we have to do is analyze the gravel content for the entire sample, which we try and collect at about a liter at a time, and that's what this is. This is an unfiltered or an unsieved backfill sample, but I already have one here that I've sieved. This is the gravel in these two, and this is the sand, and everything finer than sand as well. And we use this sieve to separate them out. And so what we're doing here is measuring the total weight of gravel and the total weight of everything that's finer than gravel, and using that to determine what the percentage of gravel is for the entire sample that was collected. Now when we do the hydrometer, we have to run a smaller sample size, but you can use the numbers from the overall sample to represent what's in the smaller sample later on. Yeah, I think that's pretty much it. It is also described in the protocol for the hydrometer if you need to see it written down and have it explained more numerically. So yeah. So now we're going to move on to the actual hydrometer test itself. First thing, you have to make sure that your sample is completely dry, and so you may have to crush it up with a mortar and pestle like this to crush any of the harder bits that result from residual moisture in the sample. You have to weigh your sample out to be 100 grams or very close to it. It doesn't need to be super precise, but the closer you can get, the better. Then the next thing that you've got to do is mix it up into a solution. You need to get a nice high-walled container like this, and then you add in, this is 100 milliliters of our deflocculant solution, which the recipe is in the protocol for the hydrometer testing and how to prepare that. And you just pour it in, and then next is cooking channel bit, where we have to use a immersion blender like this one to mix up the sample. You need the squirt bottle. We'll see why in a minute. You pour this in so that does not exceed 1 liter. I usually do about 600 or 700 milliliters. And then hopefully the power's working. I have a little bit of trouble here. Oh, there it goes. Alright, we'll call that good. Next thing we need to do is gotta clean off the immersion blender. we have a reference solution here because this is sort of our baseline. And you can see I've already got the hydrometer in here. And I'll quickly demonstrate how you read the hydrometer. You simply place it in the solution, and based on the dissolved solids that are in it, the buoyancy of the water will change, and based on how high the hydrometer floats, that tells you what mass of dissolved solids is in the fluid that you're measuring. And so we always start off with the solution, and it's reading at 1 right now, which is pretty normal because there's a little bit of the solution in there that will cause it to rise up just a little bit. Now, our first step is always going to be to measure the temperature of both solutions before we do the hydrometer test. I'm just going to do that right now. Steady at 76.6. So 75.3. Always a good idea to clean off your equipment because we don't want any sediment to stick to this probe next time for the next test that we do when we put it back in the reference solution. Okay, so now we record the temperature for both solutions and the buoyancy of the reference solution. Okay, so now for the actual hydrometer test. All that prep stuff is very important, but this is how we actually do it. So we've got some parafilm to help us seal this. We're going to mix it up even further. Even though we added the deflocculant and use the immersion blender, we try and make this watertight. We do this, we shake it up and measure 3 times so that we get enough, so we get some average readings, because it's a little tricky to get the hydrometer just right. So I'm going to start the clock right about now. Seconds. 35. Okay, 34 and a half that time. Alright, so now that we've done we've taken 3 hydrometer readings by mixing it up for 60 seconds and then putting the hydrometer in and leaving that reading. After the 3rd time, what you do is you leave the hydrometer inside the cylinder here, and you just let it sit for 2 hours, because what's going to happen is all the silt particles over the next 2 hours are going to fall out of the solution, and we'll be measuring just the buoyancy due to clay, and we can use those numbers from before and the number in 2 hours from now to get what the total amount of each type of particle size is. So see you in 2 hours. We'll have a look at what our hydrometer reading is. So it's quite simple, because we left this alone. All we have to do is come in and take a look at it, and we see that it is reading at 16. So we write that down. The second part is we also have to measure the control solution. So we take it out, clean it off, and then we just dunk it back in here where we started. And so if there's any changes, like in temperature, it might cause that reading to be different. And so that way we know we can correct both of them at the same time and correct this value accordingly. If there were any changes in the control, we can make that same change over here. So for instance, right now this is reading about 1.5. So it has changed a little bit by a half gram, and so that correction will be made in the final calculation. And that's why, and at this point, we're done. Just clean everything out and get ready to do the next sample.